first potential error in the frequently asked questions is regarding the capital of France. The question is, what is the capital of France? The answer given is London. However, the correct answer is Paris, not London. Secondly, the question asks who is the current Prime Minister of the United Kingdom. The answer provided is Boris Johnson. The error lies in the fact that Rishi Sunak is the current Prime Minister of the United Kingdom, not Boris Johnson. The third potential error concerns the highest mountain in the world. The question is, what is the highest mountain in the world? The answer given is Mount Everest. While Mount Everest is the highest mountain above sea level, Mauna Kea is the tallest mountain when measured from base to summit. Fourthly, the question addresses the largest ocean in the world. The question poses, what is the largest ocean in the world? The answer provided is the Pacific Ocean. While the Pacific Ocean is the largest in surface area, the Atlantic Ocean is actually the largest in volume. Fifth potential error is related to the painter of the Mona Lisa. The question is, who painted the Mona Lisa? The answer given is Pablo Picasso. The error is that Leonardo da Vinci painted the Mona Lisa, not Pablo Picasso. Understanding the distinction between surface area and volume is important when discussing the size of oceans. Surface area is a two-dimensional measurement, while volume is a three-dimensional measurement. This means that an ocean can have a larger surface area but a smaller volume, or vice versa. In the case of the Pacific and Atlantic Oceans, the Pacific covers a greater area of the Earth's surface, but the Atlantic contains more water overall. Consider a scenario involving electrical wiring, quite unrelated to the facts we have discussed. Imagine needing to determine the appropriate wire gauge for a circuit. You would need to consider the amperage the circuit will carry and the length of the wire run to minimize voltage drop. According to the National Electrical Code, specifically NEC section 310.15, you would consult ampacity tables to find the appropriate wire size based on the conductor's insulation type and the ambient temperature. For example, a 12-gauge copper wire with THHN insulation might be rated for 20 ohms in certain conditions. However, if the wire run is excessively long, the voltage drop could become significant, affecting the performance of the connected equipment. In that case, you might need to increase the wire gauge to reduce resistance and minimize voltage drop, ensuring the electrical device receives the required voltage. To calculate voltage drop, you can use Ohm's law and the wire's resistance per unit length, which can be found in NEC Chapter 9, Table 8. Ensuring correct voltage is important to prevent malfunction or damage to electrical equipment. Another example, suppose you are installing a 240 volts air conditioner that draws 15 amps. You need to run power from a subpanel located 50 feet away. Using a voltage drop calculator or consulting NEC Chapter 9, Table 8, you can determine the voltage drop for different wire gauges. If using 14-gauge copper wire results in a voltage drop exceeding 3%, which is the recommended maximum for branch circuits, you would need to upgrade to a larger gauge wire, such as 12-gauge or 10-gauge, to reduce the voltage drop and ensure the air conditioner operates efficiently and safely. Remember, always consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines. The NEC provides comprehensive information on wiring methods, overcurrent protection, grounding, and other essential aspects of electrical installations. Adhering to these codes helps ensure electrical safety and prevent hazards such as fires and electrical shocks. When working with electricity, always prioritize safety and follow proper procedures. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to ensure the job is done correctly and safely. Also, note that different types of loads, such as inductive loads like motors, can have different voltage drop requirements compared to resistive loads like heaters. Inductive loads can cause voltage fluctuations and require careful consideration of wire size and overcurrent protection. When selecting circuit breakers or fuses, it is crucial to choose the appropriate size to protect the wiring and equipment from overloads and short circuits. The NEC provides guidance on selecting overcurrent protection devices based on the ampacity of the conductors and the characteristics of the connected load. It is also important to consider the interrupting rating of the overcurrent protection device to ensure it can safely interrupt fault currents in the event of a short circuit. Furthermore, grounding is a critical aspect of electrical safety. A proper grounding system provides a low impedance path for fault currents to return to the source, allowing the overcurrent protection device to trip and energize the circuit. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding of metallic enclosures to ensure a safe and effective grounding system. In addition to safety considerations, energy efficiency is also an important factor in electrical design. Using energy-efficient lighting, appliances, and equipment can significantly reduce energy consumption and lower electricity bills. Consider using LED lighting, which consumes less energy and has a longer lifespan compared to traditional incandescent or fluorescent lighting. Also, properly insulating buildings and sealing air leaks can reduce heating and cooling costs, further improving energy efficiency. Regular maintenance of electrical systems is also essential to ensure safe and reliable operation. Inspect wiring, connections, and equipment for signs of damage or deterioration. Replace worn or damaged components promptly to prevent electrical hazards. Also, consider using surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors divert excess voltage to ground, preventing damage to connected devices. Finally, remember that electrical codes and regulations are constantly evolving to reflect advancements in technology and address emerging safety concerns. Stay updated on the latest code changes and best practices to ensure your electrical work is compliant and safe. Continuing education and professional development are essential for electricians and other electrical professionals to maintain their skills and knowledge.